In this video, I'd like to cover improper integrals. You may recall that these types of integrals, where one of the bounds or both of the bounds are at infinity or negative infinity, were especially important when we had the integral test in the section on sequences and series. So here are just a few statements that I have made. That the integral from a to infinity of f of x dx is the limit as t goes to infinity of the integral from a to t of f of x dx. Similarly, I have just switched these bounds and it's negative infinity to a, and the same limit, with replacing this term with infinity with t, or negative infinity here. And finally, given that these two converge, or if these two converge, then we can make a statement about the integral from negative infinity to infinity of f of x dx. Now the method for this is quite simple. I may have covered it in the integral test video. All you have to do is perform this integration without taking into account the limit. Just treat a and t as normal bounds where a is some constant. Then you should have some expression in terms of t. From that expression, then you can apply this limit and see whether the integral converges or not. So here I'll go through with an example. What I want to get is the integral from negative infinity to infinity of e to the negative x dx. Now we know that when we have negative infinity to infinity, we have to break the integral up into these two components, the integral from negative infinity to a and a to infinity. So here I'll choose a as 0. So I'll say that this is equal to the integral from negative infinity to 0 of e to the minus x dx plus the integral from 0 to infinity of e to the minus x dx. And what I have to do is evaluate these independently, and if these two are convergent, then the addition of their values will give me an expression for this improper integral. So first, let's see the integral from 0 to infinity of e to the minus x dx. So here, all we have to do is perform this integration as if it were the limit as t goes to infinity from the integral from 0 to t of e to the minus x dx. So simple u substitution makes this integral equal to, so I'll just rewrite the limit first, the limit as t goes to infinity of negative e to the minus x evaluated from 0 to t. Now this is equal to the limit as t goes to infinity of negative e to the minus t plus 1. Since we have this minus minus and e to the 0 is simply 1. Now when we apply this limit, it's clear that we can rewrite this term with e as, so I'll have the same limit as t goes to negative infinity of negative 1 over e to the t plus 1. Now e to the t becomes unbounded as t goes to infinity, so therefore this term will go to 0, and we can see that this integral is equal to 1. So this is equal, I'll write it over here, to 1. So this first integral here with the 0 to infinity is convergent. Now if this second integral is convergent, then we will have an expression for this integral from negative infinity to infinity. So let's try to integrate the other integral. So we write in the same manner, the integral from negative infinity to 0 of e to the minus x dx is equal to the limit as t goes to infinity of t minus t to the 0 of e to the minus x dx. So now this is equal to the limit as t goes to infinity of minus e to the minus x evaluated from negative t to 0. This is equal to the limit as t goes to infinity of minus 1, since we just plug in 0, plus e to the t. However, the limit as t goes to infinity of e to the t is infinity, so therefore this integral is not convergent. Recall that this improper integral is convergent if we have this limit equal to some finite value that is equal to some constant c that is not infinity or negative infinity. But because this term becomes unbounded as t goes to infinity, we cannot make this statement. So therefore this integral is not convergent, and we cannot make a statement about this improper integral from negative infinity to infinity. So this is the process of doing improper integrals. Apply the limit in the final step after performing the integration. And if the limit is finite, then a statement can be made on the improper integral. But if it is not, then no statement can be made.